Okay, the following problems are very similar to the problems that you will see on your quiz for Unit 5 two-dimensional motion. We'll start with this one. A cargo plane traveling at 220 meters per second while flying 75 meters above the ground releases a package at the exact moment it passes over a Twinkie factory. Well, in this case, I've drawn a tree instead of a Twinkie factory. First thing I'd like to point out here is the information that they're trying to give me. I see 220 meters per second, and that's the velocity of the plane, so I'm going to realize that is the velocity in the horizontal direction, 220 meters per second, and I'm going to label that. I'm flying 75 meters above the ground, so above the ground is telling me that this must be my vertical displacement, so I'll label that. At the exact moment that it passes over a tree. To be honest, I don't have the inclination to draw a Twinkie factory. Okay, it wants to know how long until the package makes impact with the ground. So of course it's asking for the time total that this package is in the air. The very first thing that I need to do is to draw a picture. So if you haven't done that, then you should draw something that looks like this. I'm telling you because drawing the picture is going to put everything into perspective. The time that this is going to be in the air is obviously unknown, and it's something that I need to solve for. But I'm going to put it between the x and the y axis because time is something that both x and y have in common with each other. In the meantime, I'm going to try to fill out my menu of stuff, so if you haven't written one, draw one now, and I'm going to fill it out as best I can given the information that I've been given up until this point. My velocity in the horizontal direction is 220 meters per second, and I want you to realize that that 220 meters per second is going to stay 220 meters per second in the horizontal direction the entire time down if we neglect air resistance. And for these problems, you can make that assumption unless they tell you otherwise. If there were air resistance, then it would not be 220 meters per second because there would be some acceleration side to side, but in Regents physics, that's generally something that we don't need to worry about. In the vertical direction, I do know a few things. Some are implied and some are explicitly told to me. For example, the fact that this is shot straight out or just dropped tells me that the initial velocity in the vertical direction must be 0 meters per second. And I'm also told that the vertical displacement is 75 meters. The fact that this is being dropped under the influence of gravity, so pure free fall, tells me that this has an acceleration of 9.8 meters per second squared. And I also know that, well, I don't know rather, but it is another property in the vertical direction, the final velocity of this. I'm just going to write it up here because I'm running out of room. So I do not know that, something I would maybe need to solve for at some point. In the horizontal direction, I forgot to finish off that the distance in the horizontal direction is something that I could find in the x direction, but I don't know it. So this is my menu, and for part A, this is what I'm asked to find. I want to find how long it's going to take for this thing to be in the air. Well, the fact that it's shot straight out is a hint because it's trying to tell you that it's as if you just dropped the package the height of 75 meters. Remember, the time that it takes for something shot straight out to hit the ground like this would be the same time that it takes to hit the ground as if it were just dropped, because gravity only cares about the motion of the object in the vertical direction. It does not care how fast it's moving side to side. It will pull it down at the same rate. So let's solve for this. How long is the package in the air before it makes impact with the ground? Well, if we have the vertical displacement, and because I'm looking over here at the x direction and I'm not given much information, I'm only given the velocity. If I were given the displacement, then I could easily solve for the time, but I don't have enough information. So I look over here at some of the stuff that I've been given. For example, my initial velocity in the y, my displacement in the y, my acceleration in the y, and I'm trying to find time. given this information, if you look at your reference table, you should see this equation, that the displacement is equal to the initial velocity times the time plus 1/2 the acceleration times the time squared. But your book, if you remember, gave you a little shortcut with this equation when the object is dropped, or its initial velocity in the y direction is 0. If that is the case, then this entire equation becomes the distance vertically is 1/2 the acceleration vertically times the time squared, or in our case, since the acceleration is the acceleration due to gravity, the displacement just becomes 5t squared. And we're rounding here because really it's half of 9.8 or 4.9. And you know what? We're in Regents physics, so I'm going to have 4.9 t squared. At this point, I can substitute in my value for the displacement in the vertical direction. It is 75 meters. And now, if I want to find how long this package is in the air, it's as simple as solving to get time alone. So I will divide both sides by 4.9, and I will also take the square root of both sides so that I can get time all alone by itself. And if you take 75 meters and divide it by 4.9, and you take the square root of that, you should solve that the time that this package is in the air is 3.91 seconds, and that is total time. So now I'm going to fill that in for my menu down below. Okay, the second part of this question wants to know how far from the tree does the package land. In other words, it wants to know if it's dropped above the tree, what is the horizontal displacement of the package. Keep in mind that this package is moving with a horizontal velocity of 220 meters per second the entire time that it's in the air. In other words, for every 1 second that it's in the air, it will move 220 meters. So we're almost 4 seconds here. But to solve for the displacement in the horizontal direction, I'm going to use this time along with this information to solve using the following equation. Velocity is equal to displacement divided by the time. Now keep in mind, I put the x here. I do not have an acceleration value in this equation because I'm moving side to side. There is no acceleration. If I solve to get time alone, rather displacement alone, it is as simple as multiplying both sides by the time. And now, if I have the time that it's in the air multiplied by the horizontal velocity, which is 3.91 seconds, times 220 meters per second, then that gives me a total horizontal displacement of 861 meters. Now the last part of this problem, and I'll just fill this in over here while I have it. The last part of this problem, it may seem a little difficult, but if you just take your time and understand, it shouldn't be that difficult at all. It wants to know at what resultant velocity does the package hit the ground. In other words, it's released from the airplane at 220 meters per second, but it wants to know what resultant velocity does this package make impact with the ground. It wants you to find for the resultant of these two velocity vectors. That is, the velocity in the x direction and the final velocity in the vertical direction, so that you could calculate what the resultant would be for those two velocity vectors. Okay, let me give myself some room here. To do this, I would need to know the velocity in the horizontal direction and the final velocity in the y direction. Taking a look at my menu, which is why I write it, I see that I do have the horizontal velocity. That won't change, so I'm already set in that regard. But I do not have the final velocity in the y direction. So the very first step of the solving part C is to first find the final velocity in the y direction. Now, keep in mind that the final velocity of this object, right before it hits the ground, we're not talking after it hits the ground, so you can't just say, oh, it's 0 meters per second. We're trying to find the velocity of it right before it hits the ground. Gravity doesn't care. The entire time this object falls, it just increases its velocity in the vertical direction as if it were dropped straight down. And we can get away with that because our initial velocity in the vertical direction is 0 for this example. It's not always 0, but in this case it is. So, to find the final velocity in the y direction, I find an equation on the back of my reference table that looks like this. And I look, do I know the initial? Do I know the acceleration? Do I know the time total? I do. It's now as simple as just plugging in those values. So 0 meters per second plus 9.8 meters per second squared times the time, which is 3.91 seconds. And I get a final velocity in the y direction of 38.3 meters per second. Okay. Now that I know the final velocity, 38.3 meters per second, now that I know the final velocity in the vertical direction, I can now find the resultant velocity of this object when it hits the ground. It is the resultant of the two components that are the vertical and the horizontal velocity. So what I'd like to do is, I'm going to take this triangle, and I'm going to move it over here. I want to solve for this resultant. To do that, it is as simple as using the Pythagorean theorem, where this side of the triangle is 38.3, and this side of the triangle is 220. To solve for that, it is a matter of using the x component squared plus the y component squared square rooted, and that will give me my resultant velocity. In this case, if I take 220 squared and add it to 38.3 squared, and if I take the square root of that, you'll need your calculator. You should get that this has a resultant velocity of 223 meters per second when it hits the ground. A resultant of 223 meters per second. But the question also asks to give the direction below the horizon. In other words, if this is the horizon, it wants you to find the angle below that horizon that the object makes impact with. At this point, it should be simple using trigonometry, using the opposite side and the adjacent side. And to do that, it is the inverse tangent of opposite over adjacent, or 38.3 divided by 220. And if you second function that in your calculator, you find that the angle below the horizon is 9.9 degrees. And that would be your final answer.